Hello, and welcome to our today's class on image processing. Today, we will try to understand what is a digital image, and we will use a library in Python called OpenCV to read an image, to display an image in the computer, to save an image. We will also try to separate different color channels of an image. We will attempt to understand the different color representations of an image, and try to split the different color channels present in color images into, so we will be converting the image, a color image to grayscale image. We will describe what a grayscale image is. We will also try to generate image histograms from grayscale images. And lastly, we will learn how to convert a grayscale image to binary image, yes. What's a digital image? In the way a computer represents an image, it represents it in form of a matrix of numerical elements. So you know an image is like a mathematical variable with two dimensions. The spatial dimensions, there is the length and the width or the height of the image. You'll find cameras will say it gives an image in different dimensions. It could be 600 pixels by 400 pixels, whatever dimensions you will find. Those expresses something like a mathematical matrix, a two-dimensional matrix with values, pixel values. So a pixel is like an element, a picture element. So it's a very small region in an image, the smallest region in an image. And from the physics point of view, a camera, you have to understand how a camera works. So a camera consists of what we call a sensor array, image sensor array. So it's many sensors packed in like a rectangular fashion. So each sensor will pick light intensity coming from a given point, and all these are converted into numerical values. They are assembled and they give an impression of an image. Although under the hood, those are mathematical values in form of matrices. Now, this is what we call grayscale image, which is an image that only contains the brightness of an object. So it can be either bright or dark. So if you look at a grayscale image, you only see either bright regions or dark regions, or in between, which is grayish regions. So it doesn't have any other color. But if you have a color image, then you can see distinct colors of that image. So a grayscale image has got only two dimensions, but a color image has got three dimensions. The 2 dimensions represent the spatial coordinates of the image. And the third dimension represents the color. So each is like a matrix, a 2x2 matrix, where you have different colors stacked together to form like a 3-dimensional matrix. So with that understanding, then we can jump into processing images using Python. And the library to do the image processing for the most part is OpenCV. So if you look at my code, I am importing the library for that will help us to process the images, and that is OpenCV. So we import it as CV2. Then, of course, by now you understand what NumPy is. It's a library that we use for manipulating numerical arrays. We can be able to do mathematical operations if we convert whatever sort of arrays into NumPy arrays. And then we also need to import matplotlib for helping us graph or visualize our data. So I ran that code, and the libraries have been imported. So the next thing I'm going to do is read an image that is saved in the directory where my Python is running from. So that image is titled OpenCV1. Actually, it's an image of myself in my library, a simple library. So when I run it, it will read that image and bring it into the Python environment. So that code has successfully run, and now the image has been read and saved as a variable img. So that's how we are saving the image I have read from the directory there. The next thing I want to do is to display that image and see how it looks like. So and before I go there, to read the image, you use the function in OpenCV called imlint, and you supply it the name of the file that you want to read, the name of the image file you want to read. If it is in the same directory as the Python, where Python is running from, then just the name will suffice. But if it is in a different path, then you need to indicate the path explicitly. So now we go to displaying the image, and the next set of commands achieve that. The first thing is to call the imshow method. It's an inbuilt method for OpenCV, and you supply the name of the window that will contain the image and the image variable. Remember the image variable, we already had read the image and called it img. So sorry, I think we got disconnected a bit, so let me share the screen again. All right, so I was describing how you display the image, and I was saying you call this function imshow. It's a function in the OpenCV CV2. You supply two things there: the name of the window that contains the image you want to display, and the name of the image. In that case, we had already read the image and saved it as img. So next is we tell Python that in case to listen for a key being placed, and if a key is placed, it should close that window. So if I run that set of commands, so what do we see? Voila. I hope you are able to see this image. So it's an image. And if I want to close it, I only need to place any key from my computer and it will be closed like so. Now, the next thing I want to do is, since I have learned an image, I want to save it in a different location. In fact, I want to save it in my desktop directory. And so I give the path to my desktop directory. As you can see, my path is as follows, up to there. Then I give the name of the name that I want to call the image. Okay, I want to call it photo.jpg. So that's the extension, the file extension for the image. Of course, I have to also have this prefix R, basically to help Python to know that that's a relative path to the path we are in currently. The next thing is to use the method that actually does the writing of that file, and the method is imlite, cv.imlite. I supply the path, then the destination path that I indicated earlier, and the image I want to save. So if I run this, yeah, it tells me it has done so by returning true. Now, if I wanted, I could check whether indeed the image has been saved, but you can trust my word, the image has been saved. You want to confirm whether it has saved the image anyway. The next thing I want to do is I want to now change gears and tell you how you can convert this color image. You see the image here. How do we convert this image? This is a color image. In fact, it's a BGR image. When you read an image in OpenCV, then default is it will read in BGR. BGR, well, it's a version of expressing color images. Is a way of saving color images. But what you need to understand is that a color image is actually a composite of 3 grayscale images stacked together. And the way they are created is the camera has got whatever I call the image sensor array. At each location, you have got like 3 sensors. One sensor that picks the red color, another sensor that picks the blue color, another sensor that picks the green color in a very small region. So you have many of them. So that's why we are calling them image sensor array. It's an array of sensors. So when now a color image is reconstructed, you have a matrix representing each one of those 3 colors stacked together. So you have 3 matrices. So that's, if you look at it, then it's a 3-dimensional array. With the 2 dimensions representing the spatial coordinates, and the 3rd dimension representing the colors. So then we got a color image, which can then be represented in either a style we call BGR, where you start with the blue channel or the blue matrix, then green, then red. You could also have what we call RGB, where you start with the red channel, then green channel, then blue channel. So, but I'm saying by default, unless you specify when you are reading an image in OpenCV, it will read it in BGR. So this image we are seeing is in BGR format. So now if I wanted to convert it to grayscale, what I need to do is call this function here, CV convert CVT. I think this stands for convert color. And then you pass the following arguments: the image that you want to convert, which then should be in BGR format, and the output format. Here we are saying the format should be BGR to grayscale image. So you pass the image you want to convert, and also you pass an argument to tell OpenCV the format you want it converted to. In our case, we want to convert BGR to grayscale. Then it returns a grayscale image. So now if you display what it has returned, we expect it should be in grayscale. Let's see that. See, now I have got a grayscale image. It's no longer a color image, it's a grayscale image. It's an image with only intensity values. So some regions are bright, so they appear as whitish. Some regions are dark, so they appear as brackish. So it's a grayscale, so we call it a grayscale image. So we proceed. The next thing I want to do is, well, I was trying to play with a few things here, but I want to generate what we call an image histogram. An image histogram shows the distribution of intensity, the distribution of intensity values in an image. So it's like pixels, how many pixels contains or possess a given intensity value. An example, how many pixels contains a value, an intensity value of 0. This is the very darkest color intensity that can be represented in an image. How many pixels in an image contains 255, a value of 255? Because a grayscale image will have its pixel values range from 0, that's the darkest point of the object, to 255, which is the brightest value. Again, this assumes that your image is in 8-bit whatever 8-bit data format. If it is in a different data type, again, it will depend. Mostly we work with 8-bit data types for images, grayscale images, or sometimes we want to normalize it so that the intensity values range from 0 to 1, and for that we call that floating point data type. You could also have 16-bit data types and that 2-bit data type. So yeah, but mostly if it's a grayscale image, its pixel values will range from 0 to 255, 0 being the very darkest point and 255 being the very brightest point. So the histogram then will give you pixel distribution. How many pixels consist a given grayscale value in the image. So that distribution is what we are calling image histogram. So how do we generate an image histogram from a grayscale image? So we call a method in matplotlib that is called hist. We pass the image, the grayscale image. We want to get it histogram. We tell it to level that image. You see, an image is, this grayscale image is a two-dimensional image. So what we are saying is flatten it and make it a one-dimensional image. Then convert that image into how many levels? 256 intensity levels. And then these intensity levels should range from 0 to 255. Then it will plot the histogram. And for the most part, that's it. What I wanted to show next, I think I deleted the command, is how to do the thresholding so that I can generate a binary image. And the way I do that is, of course, I return my binary image. I say I have two variables which I expect to be returned. And I say CV2 dot most of these commands you sometimes cannot memorize them. So threshold, then pass the image you want to threshold. In my case is image gray, then grayscale image. And what I want it to do is to threshold those pixels, all to convert every pixel that is above, that has a value above 120. Remember, my grayscale image has got pixel values ranging from 0 to 255. So I can decide what would be a threshold value that I want to convert all pixels above that threshold value to be white, and all pixels with the intensity values below that becomes dark. So it's like a binary image is actually a black and white image. So in my case, what I could do is, for example, I could set a threshold value. Sometimes you are informed by the histogram. So for example, we can see this histogram has got a major peak at this region. So I can say, maybe I want to threshold all pixels below something like 140 to be black, and all pixels above 140 to be white. So I say 140 is my threshold value. Anything above it, make it 255. Okay. So if I do that, then I also have to tell it which thresholding method to use. In my case, I use a simple binary threshold value, which in OpenCV, I just say thresh underscore binary. Okay, so I ran that. tells me there's a problem with thresh, and the problem is it's not supposed to be thresh, but it's supposed to be threshold. Sorry. Oops. Thresh. It's not. Oh, it's complaining because it's saying IMG in gray is not defined. So let me check how I defined my grayscale image. It's not IMG, but IM. It's IM. Oh, now it has accepted. So let us display this. So we say CV2.imshow. Then we read IMG binary. First of all, of course, I need to define the window that the name of the window that will be used to put that image. So I just call it window for lack of a better word. And I also need to tell it to wait for any key to be placed. So wait key 0. And then if a key is placed, then we do cv2.destroy all windows. So let's run that. And there we are. We have our binary image. So it's now a matter of whether this binary image is satisfactory. If it's not, we change the threshold value. So let's try to change the threshold value. Let's try to reduce it a bit. Instead of 140, let's change it to 120. Aha, now you can start seeing the person is a bit appearing more clearer. Let's make it 100, maybe. See how whether it is. Aha, now you can clearly see even the nose appears, the eyes. Let's try to make the threshold value 80. So all pixels above 80 are made white, and all pixels below 80 are made black. Look at that. Look at that. So that's what thresholding to get a binary image entails. I think we can stop there and do a bit of practice on that. So what I would like you to do is download an image, try to read it using OpenCV imread. When you read it, try to save it in a different location. When you do that, also try to separate. Maybe one thing I didn't discuss with you is how to separate the channels. Because I said if you read an image like the way I read mine, it assumes we are reading it in the default mode, which is BingR. So if then you want to split that image into the 3 constituent channels, you can do that using OpenCV method we call split. But even before we do that, you might even want to ask yourself, what is the shape of this image that we have read? And the way you do that is you you inquire about the shape of that variable, like so. Or you can't use shape directly. So what we can do is we can convert that variable into numpy array. So we can say image np is equals np.array. So we are converting the image we have just learned into a numpy array. And then we can call the shape img np.shape. So when we run that, so you see our image is 480 pixels. That is the number of pixels along the rows. So the rows are the things that are run downwards. That lands like this. So it has got 480. Sorry, I think I'm confusing you. The rows are the numbers that run horizontally, one below the other. So they are like 480 rows and 640 columns, things that run vertically like this. So it's an image with 480 by 640 pixels, and it's by 3. What that 3 tells you, it has got 3 color channels: the blue, the green, the red. If you wanted, you could split those color channels. And the way you do that is you call OpenCV like this: BGR equals cvtune.split, and pass the image you want to split, img. It has done that. So if you wanted to display, for example, the blue channel, what you would do is now call cvtune.imshow. You can as well use matplotlib library, function for displaying. So we could say plt.imshow. And then we do B. We want to display B, and the color format is gray. We want to use gray. See now. So that's the blue channel. That's the blue channel. How it looks. It's actually a grayscale image. It's actually a grayscale image, but that's the image that is acquired using the blue color sensors from the camera. Remember, I said in the camera, you have the red color sensors, you have the blue color sensors, and you have the green color sensors. So when you superimpose the data from all those color sensors, you get a color image. So if I display the red channel, that's how it looks like, the red channel. The green channel, that's how it looks like. Okay. So you want to try that. You get an image, split it, and see, try to display in different channels. Then convert it to grayscale. Get the histogram of that image, and then try to threshold to get a binary image. So I think with that we can stop there. Yeah, and you can let me know if you have any difficulties, any problems. Yeah, so can stop at that point.